Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So here for part A, we know that the skier covers a distance delta x. We can say that this is equal to L. We know that the skier's initial speed is going to be equal to 0 meters per second. And we can say then that if she moves with a constant acceleration, we can use kinematics and solve for this constant acceleration. So A sub 1 derived from the kinematic equation will equal 2 times L divided by T sub 1 squared. This is equaling 2 times 200 meters divided by 61 seconds quantity squared. This is giving us 0.11 meters per second squared. We're going to say that subscript 1 is for the old skis. For part B, we want to find the acceleration of the new pair. So we can say that the subscript 2 would be for the new skis. And we can say A sub 2 would then be equal to 2 times L over T sub 2 squared. This is equaling, again, 2 times 200 meters. However, here it would be divided by 41 seconds quantity squared. This is giving us 0.23 meters per second squared. At this point, we can solve for the net force along the slope acting on the skier with a mass of m. So for part C, we can say force net would be equal to mg sine of theta minus the kinetic force of friction, because again, the skier is moving, so we'll be using kinetic force of friction instead of static. This would be equal to mg times sine of theta plus the coefficient of kinetic friction times cosine of theta, where mg cosine of theta equals the force normal. This is going to equal the mass of the skier times the acceleration of the skier. We can then solve for mu sub k sub 1 and say mu sub k, the coefficient of kinetic friction sub 1, so this would be for the, again, for the old skis, would be equal to tangent of theta minus the acceleration of the old skis divided by g cosine of theta. So this would be equal to tangent of 3.0 degrees minus, we can say 0.11 meters per second squared divided by 9.80 meters per second squared multiplied by cosine of, again, 3.0 degrees. And we find that the coefficient of kinetic friction for the old skis would be 0.041. Now, for the second pair, we can use the exact same relationship and say mu sub k sub 2. So this would be the coefficient of kinetic friction for the old, for the new skis. This would be tangent of 3.0 degrees minus, and here it would be 0.23 meters per second squared divided by 9.80 meters per second squared multiplied by cosine of 3.0 degrees. And we find that this is equaling 0.029. So this would be our answer for part D for the coefficient of kinetic friction for the new skis. And for part C, this would be your coefficient of kinetic friction for the old pair of skis. That is the end of the solution. Thank you for watching.